In this video, we are going to go over how to graph rational functions. So first, what is a rational function? A rational function r of x equals fx over g of x. It's a fraction, and both f of x and g of x are polynomials. That means there will be no terms like x to the negative number or square root of x, something like that. So fx and gx are polynomials, something like x to the fourth plus 3x plus 2. So there are three types of rational function we have to be able to graph. First, just a regular one, f of x equals 3x squared minus 12x over x squared minus 2x minus 3. So when we graph rational functions, the first step is always factor. So f of x equals 3x, x minus 4 over x minus 3, x plus 1. We are going to find all the useful information. So x-intercept, the numerator has to be 0. So x times x minus 4 equals 0. So x equals 0 or x equals 4. So the x-intercept is 0, 0 and 4, 0. Y-intercept, we set x equals 0. We plug x equals 0 into the original equation. So there will be 0, y equals 0 over negative 3 equals 0. So the y-intercept is 0, 0. Vertical asymptote. So vertical asymptote, why there's a vertical asymptote? X cannot be that number because when x equals that number, denominator equals 0. So we set denominator equals 0. So x equals 3 and negative 1. Horizontal asymptote. Horizontal asymptote, we just need to find the limit as x approaches positive, negative, infinity, f of x. We look at the power. The power here is 2 and 2. They're the same power. So the limit equals 3 over 1 equals 3. So y equals 3 is a horizontal asymptote. Because the power is the same, so there will be no slant asymptote. Last step, we need to do the sign analysis. X-intercept 0, 0, 4, 0. Y-intercept 0, 0. And x equals 3. And x equals negative 1. Horizontal asymptote y equals 3. So if we look at, we have two vertical asymptotes. So these two vertical lines divide this whole xy plane into 3 pieces. So we are going to have 3 branches. Now we are going to use sign analysis. So this is x-axis. We have negative 1 and we have positive 3. So we are going to choose a negative number on the left and right of negative 1. For example, negative 0.9 and negative 1.1, 3.1, 2.9. So we are going to plug all these numbers into the factored form to check the sign. So we plug negative 1.1 in. So it's negative times negative over negative times negative. Give us positive on the left. So on the right, negative 0.9 give us negative here. 2.9 in give us positive on the left. 3.1 in on the left of negative 1. It will be positive infinity here. On the right of negative 1 had to start from negative infinity. Go across this point. And on the right of 2.9 it's positive infinity. So it has to start from there. On the right of 3.1 start from negative infinity. And we'll approach horizontal asymptote. Let's look at example 2. Given f of x equals 2x squared plus 10x plus 12 over x squared plus 3x plus 2. Step 1, factor. F of x equals 2 times x plus 2, x plus 3 over x plus 2, x plus 1. Because x plus 2 is cancelled, so there will be a hole here at x equals negative 2. We can plug in x equals negative 2 into a simplified function. Give us y equals 2 times 1 over negative 1. Give us negative 2. So our whole will be x equals -2, y equals -2. After we factor it, we are going to find x-intercept, y-intercept, same thing as before. So x-intercept in this case will be, we set a numerator equals 0, x plus 3 equals 0, so x equals -3. Y-intercept, we plug 0 into the original equation, so 0, 6. And vertical asymptote, as the denominator x plus 1 equals 0, so x equals -1. The horizontal asymptote, limit as x go to plus minus infinity, f 2 over 1 give us 2. So before we do the sign analysis, let's put everything here on the graph. -3, 0, 0, 6, x equals -1. There's one vertical asymptote. There is a horizontal asymptote, y equals 2. So there will be two pieces on this graph, one on the left, one on the right. So now let's have a look at the sign analysis. So -1 on the left, we'll pick -1.1, on the right, -0.9. We are going to plug these two numbers into the simplified version. So -1.1 give us positive over negative, so it's negative on the left. On the right will be positive over positive, give us positive. So on the left of -1, because it's negative, we'll start from -infinity, go across this point and approach this line. On the right, start from positive infinity, go across the y-intercept and approach this line. Let's look at example 3. Given f of x equals x squared plus 2x over -4x plus 8. So first, we factor it. So f of x equals x times x plus 2 over -4 times x minus 2. So there's nothing canceled, so there will be no hole in the problem. And also we realize the numerator power is 2, the denominator is 1, so there will be a slant asymptote. So same thing, let's find an x-intercept, y-intercept, vertical asymptote, and horizontal asymptote. X-intercept, we just set numerator equals 0, so x equals 0 or -2, 0, 0, -2, 0. Y-intercept, we just plug in x equals 0. So when we plug x equals 0, use the original function. So 0 over 8 give us 0. So here, use original function. Vertical asymptote, we look at the denominator equals 0, so x equals 2. The horizontal asymptote, because the numerator, the degree of the numerator is higher, so there's no horizontal asymptote, but there will be a slant asymptote. The slant asymptote, we have to use long division. X squared plus 2x divided by -4x plus 8. We look at the highest power. So -4x multiplied by -1/4 x will give us x squared minus 2x. Do the subtraction, give us 4x. So -1 here is 4x minus 8 give us 8. So this is our slant asymptote, y equals. Let's put everything on the xy plane. So 0, 0, -2, 0, 0, 0. X equals 2. Y equals -1/4. The sign analysis. So at 2, 1.9, 2.1. Plug those points into the simplified version. So it's plus, positive over, negative times negative. Give us positive on the left. And 2.1. Positive, positive, negative, positive. Give us negative on the right. The graph will look like and from -infinity